You are hungry at 11:45. At 11:47, a message arrives. The presentation has moved up, and you are speaking in 20 minutes. The sandwich in front of you has not changed, your stomach has. Hunger disappears, your mouth feels dry, the first bite seems to sit behind your ribs. A few minutes later, your stomach feels frozen while the rest of your gut is considering an emergency exit. The usual explanation says your body shut digestion down and sent all the blood to your muscles. There is a piece of truth in that picture, but it misses most of the control system. Stress changes instructions across the brain, vagus nerve, sympathetic nerves, hormones, stomach, and enteric nervous system. Different parts of the gut can respond in opposite directions during the same event. Your stomach has not broken. It has received a different set of instructions. The sandwich normally triggers a coordinated sequence. Your stomach relaxes to receive food, muscles mix it with acid and enzymes, controlled contractions move material toward the small intestine, signals from stretch, nutrients, and gut hormones travel locally and back to the brain. Much of this work is coordinated by the enteric nervous system, a network of neurons built into the digestive tract. It can run local reflexes without waiting for a conscious decision. People sometimes call it a second brain. That name exaggerates its independence. The brainstem, hypothalamus, vagus, sympathetic nerves, endocrine signals, immune cells, and the gut's local circuits keep changing one another. Because control is distributed, stress can alter several digestive functions without turning every part off. The presentation notice is not physically inside your stomach. Your brain interprets it as a demand involving status, uncertainty, and control. Stress-related networks in the hypothalamus and brainstem begin changing autonomic and hormonal output. One important messenger is corticotropin-releasing factor, usually shortened to CRF. CRF helps organize parts of the stress response. It influences the pituitary and adrenal system, and it changes autonomic pathways that control the gut. Related peptides and receptor subtypes can produce different effects in different regions. Adrenaline is part of the wider response, but it is not the single command responsible for your stomach. Central signals can change the vagal output reaching gastric circuits. Sympathetic pathways can contribute. Local enteric neurons keep processing stretch, chemistry, and motion under those altered conditions. The stomach changes because the network controlling it has changed state. A stomach receiving a meal has several jobs. Its upper portion must relax enough to make room. Muscles in the lower portion grind and mix. Waves of contraction help meter material into the small intestine. Acute psychological stress can reduce gastric contractions or delay gastric emptying in some people and experiments. A human study published in 1991 measured gastric emptying during psychological stress in healthy subjects and found that stress altered the process. Other human work and physiology reviews connect stress-related gastric changes to vagal output, sympathetic pathways, and CRF signaling. The result can feel like fullness, pressure, nausea, or a meal sitting longer than expected. The stomach does not become motionless in every person. The size and direction of the effect depend on the stressor, meal, timing, and individual physiology. Still, the impossible sandwich now makes sense. Your upper digestive tract may be running a slower or less coordinated motor pattern, while attention is fixed on the presentation. The simple shutdown story runs into trouble when the lower gut joins the scene. Stress can inhibit upper gastrointestinal movement while stimulating parts of the colon. CRF-related pathways help produce this regional split. Different receptor systems and autonomic routes participate. This means a person can have a heavy, slow stomach and urgent lower gut activity during the same stressful event. The stomach and colon were never one conveyor belt controlled by a single speed dial. Each region has different muscles, circuits, reflexes, and functions. Stress changes the pattern, and the pattern can point in opposite directions above and below. That is why my stomach shut down and I suddenly need a bathroom can describe one nervous morning without contradicting each other. At 11:45, the sandwich looked excellent. 2 minutes later, it might as well be cardboard. Hunger is not a simple fuel gauge. Signals from the stomach and intestine interact with brain systems tracking energy, reward, learned cues, and current demands. Acute CRF-linked responses can suppress food seeking. Nausea, dry mouth, and altered stomach movement add practical reasons not to eat. Stress does not always reduce food intake. Some people eat more, timing matters too. An immediate alarm response, later cortisol effects, habit, reward, and the type of food available can pull behavior in different directions. Our narrator lost lunch during the short surge before a presentation. That is one common pattern, not a rule for every person or every stressful week. The body can suppress appetite now and seek highly rewarding food later without changing its mind at random. The signals and the situation changed. What about the claim that blood leaves the gut and rushes to the muscles? Intense physical stress can redistribute circulation. Sympathetic activation changes heart rate, vascular tone, and blood flow. In hemorrhage, shock, or extreme exertion, circulation becomes a major part of the story. The everyday nervous stomach feeling is not fully explained by a hose valve draining the digestive organs. Neural commands can change stomach contractions before any dramatic circulation shift is required. Hormones, secretion, sensitivity, and local enteric reflexes also affect the sensation. The blood flow image survives because it is simple to draw. The actual control system has several routes acting at once, often with different effects in different tissues. It is tempting to say digestion stops so your ancestors could run from lions. That illustration is memorable, but it is not a complete evolutionary explanation. Stress responses operate across many challenges, including injury, cold, conflict, infection, uncertainty, and physical effort. Changing gut activity during an acute challenge can keep one slow, energy-demanding process from continuing unchanged while the rest of the body's needs are shifting. It can alter what moves, what is absorbed, what is expelled, and which sensations reach attention. The response is flexible, which is why people do not all lose appetite or develop the same gut pattern. A flexible regulatory system fits the evidence better than one ancient escape switch. 20 minutes later, the presentation is over. The slides worked, nobody attacked, your hands stopped shaking, the sandwich still looks slightly suspicious. As the acute response eases, autonomic and brain-gut signals can move toward the earlier state. Gastric patterns do not restart like a computer. They settle through changing nerve activity, hormones, local reflexes, and the arrival of food itself. For many people, appetite returns. Sometimes it returns slowly, sometimes the later rebound points toward the most rewarding food in the room. The stomach was never disconnected. It remained part of the stress response throughout the presentation. That distinction also explains why the sensation can linger after your thoughts calm down. Nerve and hormonal signals do not have to change at exactly the speed of conscious relief. The event can be over while the gut is still moving back toward baseline. So why does stress shut down your stomach? Usually, it does not shut digestion down completely. Stress changes a distributed brain-gut control system. CRF-related signaling, vagal and sympathetic pathways, enteric circuits, stomach muscles, sensation, and gut hormones shift the pattern. The upper gut may slow, while the lower gut speeds up. Appetite may vanish during the immediate alarm and return later. The sandwich did not become inedible. One message changed what the body expected to do next. Your stomach was working the whole time, just under different instructions.